Good day, everyone. Today we are looking at production and propagation of sound. And what we are going to be considering in this topic is solving some past questions from WAEC, NECO and UTME on this topic. But just before we do that, let's quickly look at a brief introduction into sound waves. Now, sound is produced as a result of disturbance caused to the surroundings air by vibrating bodies. And in another word, you can say sound is produced as a result of vibration. Now, this disturbance travels out from the source of vibration in form of longitudinal wave. Another thing that we can bring out from that is that sound is a longitudinal wave. And to buttress that point, sound waves are transmitted through a material by displacement of the molecules of the material in the direction parallel to the source producing it. That's another statement that is establishing that a sound wave is a longitudinal wave. Now, sound cannot travel in a vacuum because it needs material medium for its propagation, and that tells us that sound is a mechanical wave. Now, when this sound is transmitted, the speed of sound in air at any given temperature is directly proportional to the square root of that temperature in Kelvin. So that is what we have in the statement that we have here in this expression. So, and that will lead us straight away to our first example. Like I said at the beginning, we are considering past questions, basically calculation on this topic from the likes of WAEC, NECO, UTME, and other examination, and how to tackle a future problem on this topic. Okay. Let's continue by moving to the first example that we have here. Okay, in our example 1, the question says, if the speed of sound at 17 degrees Celsius, that is the speed of sound at temperature 17 degrees Celsius, is still around 40 meters per second, we have to determine the speed of that sound when the temperature rises to 137 degrees Celsius. According to this question, our first temperature is given as 17 degrees Celsius, and the value of that in Kelvin is 290 Kelvin. I want to believe we all know how to do that. Remember that temperature at Kelvin equal to the degree Celsius value plus 273, and that is where our 290 is coming from. So also our second temperature given 137 degrees Celsius converted to Kelvin will give us a 410 Kelvin. Okay, and here we have the temperature. We have the speed at temperature of 17 degrees Celsius, and they ask us to look for the speed at temperature 137 degrees Celsius. And from the relationship, from the expression that the speed is directly proportional to the square root of temperature in Kelvin, from this it means we can say V over root T equal to constant, and this can easily lead us to mathematical equation by saying V1 over root T1 equal to V2 over root T2, which can as well give birth to this equation that we have here. So this equation we are seeing here is coming from this derivation here. So now this will be very, very useful for us in solving problems. As we are looking at the screen here, this question is a past UTME question. Okay, now fitting all these parameters given in this question into this equation, we can make our V2 the solution to the formula from this equation, and that will give us this, since we are looking for our V2. Okay, now with that, inserting the values of other parameters, we have the value of our V1, which is 340 from the question, and T2 is 410, and our T1 is 290. Mathematically, this will give us 404 meter per second. That is the speed of sound in air at temperature 137 degrees Celsius, which is also equal to 410 Kelvin, is equal to 404 meter per second. Okay, let's proceed to the next part of this discussion. Now, like we've been saying about sound, sound is a longitudinal wave, which means a sound will also obey wave equation. Sound as a longitudinal wave obeys wave equation, and I believe we can still remember this wave equation from our previous topic. V equal to F lambda, where V represents the speed of sound in air, our F represents the frequency, and lambda represents the wavelength. So we can as well use this one in solving problems. Okay. Now the second example here says a plugged guitar strings vibrates with a frequency of 265 Hz. We have to calculate the wavelength of the sound produced if the speed of sound in air is 343 meters per second. Now, according to the question, the parameters in this question are frequency of 265 Hz. We have the speed of sound in air at that given temperature at that particular time as 343 meters per second, and we are looking for the wavelength. Now, from this expression, V equal to F lambda, making lambda the subject of the formula, we are going to have this, and substituting the value of given parameters into the question. This is our V divided by frequency, and that will give us the value of lambda to be 1.29 meter. Okay, let's move away from this and go to another subtopic that is under this production and propagation of light. We quick briefly look at echo. As we all know, echo is a sound reflected from a flat surface. Remember, sound wave is also is a longitudinal wave, so a sound wave can as well experience almost all the properties of waves except polarization, which is a properties of transverse wave, because a sound wave is a longitudinal wave. So echo is a reflection of sound from a earth surface. When sound experiences reflection, that is when we call echo. That is when you produce a sound and you hear the sound after few seconds or after few seconds again you hear the sound. That is what we call echo. Now, if this reflecting surface that is producing the echo is very close to the source of the sound, and there's continuous generation of sound, there will be a prolonged multiple reflection of sound, and this phenomenon is known as reverberation. So this is just a brief introduction into echo and reverberation. There's still more to discuss on echo and reverberation, and for comprehensive explanation on this topic, you can consider your text, or probably you can reach out to us. There are some materials that available for these topics in preparation for any exam of your choice. Okay, that's why reverberation is defined as the multiple reflection of sound from the ceilings, walls, and floors of an auditorium, such as a musical studio, concert hall, broadcasting rooms. That is when you hear multiple echoes. The name given to that is reverberation, and this echo has a lot of applications, in which I'm going to just look at one of them because of what we are doing here. What we are doing here is just solving calculations related to all these topics, coming from our WAEC, NECO and UTME examination and other examinations like GCE and NECO GCE. Okay, now the only application of echo we are considering here is the last one that we have here. Echo is used in determination of speed of sound in air, using the relation that we can see on the screen, that if we can use this relation to determine the speed of sound in air when echo is produced. Also, these relations can help us in determining the distance between the source of sound and the surface that is reflecting the sound. Okay, let's consider our first our first example here, which will be our example 3 in the topic. The example says a sailor heard the echo of a sound wave sent from the ship towards the seabed after 2 seconds. Now, if the velocity of sound in the sea is 1490 meters per second, calculate the depth of the sea. As we can see here, the depth of the sea serves as a reflecting surface, while the velocity of sound in the sea is given as 1490 meters per second. And when the sound is produced, the echo is heard after 2 seconds. Now we can put all this into the calculation and make d, which is the distance between the source of sound and the reflecting surface, the subject of the formula in this expression. And that is what we did basically here. And d is now equal to vt over 2. Now substituting the value of v and t into that equation, v equal to 1490 according to the equation, our t equal to 2 seconds, and dividing it by the 2 in the formula, we have the depth of the sea as 1490 meters. Okay, let's say maybe we have one more question on echo before we move on. Okay, another question here on echo is saying a boy standing in front of a tall tower claps his hand and receives the echo after 1.5 seconds. If the sound emitted has a frequency of 246 Hz and a wavelength 1.4 meter, we have to calculate the distance between the boy and the tower. Now, if you look at this question very well, instead of us having the speed of sound in air, we were given the frequency and the wavelength of the sound. So what this one will be used for is to quickly calculate the speed of sound in air. And speed, remember the general wave equation, speed equal to frequency multiplied by wavelength, and that is what is happening here. Our frequency is 246 and our wavelength is 1.4. So the product of that will give us 344.4 meters per second. Now then we can now use the value of this speed calculated here in the expression d, or equation rather, d equal to vt over 2, which is used in determining the depth or the distance between the source of sound and the reflecting surface. And substituting the value of v into this equation and the value of our t, which is 1.5 seconds according to the equation, we are able to arrive at 258.3 meters as the value of the distance between the tower and the boy that is producing the sound. Okay, let's move to example number 5. In example number 5, the question says a man standing between two cliffs claps his hand and hears two echoes after 3.6 seconds and 4.2 seconds respectively. If the speed of sound in air is 340 meters per second, we have to calculate the distance between the cliffs. And what this question is telling us is that a man is standing probably between two cliffs. That is, cliffs are P and Q. And when the man produces a sound, definitely the man will hear two echoes because the sound will be reflected from this cliff and from these cliffs as well. But we do not have the distance of the man in between the cliffs, so that is what we are looking for basically, and to know the distance between the two cliffs. Okay, now according to the question, the time taken for the sound to come back to the man from one of the cliffs is 4.2 seconds, while the other one is at 3.6 seconds. This one can easily help us in calculating the distance between the man and each of the cliffs. Okay, let's consider the distance between the man and the cliff Q as distance D1 that we have here. Now, using the prefix equation we've been using, that is D equal to Vt over 2, we can say that from what we have here, we can say that D1 will be equal to VT1 over 2. We choose this as T1 because the distance that D1 represents is a bit longer than what D2 represents. Therefore, the time for the sound to come back to the man from this D1 will be a bit longer than the time taken for the sound to come from cliff P. That is, the distance of the man from cliff Q is longer. It's a bit longer than distance of the man from cliff P. That is what we are saying. That's why we choose the longer time for distance between the man and cliff Q. And substituting all this into the expression or the equation here rather. So this is our speed, this is the time divided by 2, and this will give us 714 meters. That is the distance between the man and the Q cliffs will be equal to 714 meter according to this formula. Similarly, the distance between the man and cliff P, which is D2, and the time will be 3.6 seconds. Using that, we have the distance to be 612. So distance D2 equal to 612 meter. So now, to know the distance between the two cliffs, we can easily add D1 and D2 together, and that is what we did here. Since D represents the distance between the two cliffs, which is equal to D1 plus D2 according to the diagram, so the distance between the two cliffs will be equal to 714 plus 612, and this will be equal to 1326 meter per seconds. Okay, with this we come to the end of the problem, the calculations in this topic. Please, if you do have some other question that you are struggling with, feel free to drop the questions at the comment section. It will be attended to, and we'll forward the question, we'll forward the solution directly to your probably your email address or whatever channel you provide them. But just before we go, please always remember to subscribe, to click the subscribe button if you've not subscribed to our channel, so that you will be notified when we release subsequent videos. And also, please, if you love this video, please kindly like the video. Please help us do that. And just before you go, let me quickly introduce to us one very good practical book that can help us in some of the exam that we write. The name of the book is Reform Physics Practical Book, and this book has a lot of practical exercises for year 10 to year 12 students, that is SS1 to 3 students, and also it has practical exercises, alternative practical exercises, that is alternative to practical for GC candidates, NECO GC candidates. The book is is developed in such a way that student can just pick it up, study and understand what to do in any practical. The book is very, very good in practical, and also we've explained so many things in the book in one of our videos in this channel. You can check on the video that talk about how to actually undo your practical physics, and also we have a video on alternative to practical physics for GC and NECO GC candidate. Please, if you need a copy of this book in case you are preparing for any of these examination mentioned, you can reach out to us on the number listed on the screen, or probably contact us through this email address. Also, you can get the soft copy of this book from this link on Amazon. Just click on the link and get a soft copy of the book. And also other services that we render includes but not limited to online tutorial for the preparation, for student preparation in all the examination listed on the screen here. If you are interested in our online tutorial for your WAEC, NECO, UTME, Cambridge IGCSE, Cambridge A-Level, and other examination, please just contact the number on the screen on WhatsApp, and let's have discussion, and we'll know how to go about it. And just before I go, please, I will need to say this again. If you are yet to subscribe to our channel, please kindly do, so that you be notified when we release our subsequent video. Thanks for watching.